increasing and decreasing intervals. We call it the first derivative test. And we've already got a few of the ideas in here, but let's just take a look at the first box here. Increasing or decreasing interval test. Suppose that the function is continuous on this open interval between two numbers, c and d. If the derivative is positive, right, that means derivative is positive, greater than 0, for all values of x on that interval, with the exception of a few points. So you can have a few points where it's 0, the derivative is 0, but never switches to negative. Or even doesn't exist, maybe there's a hole. So, asymptote. And then f is, I said that's not right. There's not a hole. It's like this. It's like a corner. Maybe. I made a mistake. Then f of x is increasing. Okay? So basic idea here is, maybe underline that, and then the word increasing. That's what I mean, left to right, increasing, okay, when you graph it. We'll get an idea. And then the opposite. If f of f prime of x, the derivative is smaller or negative, pardon me, then it is decreasing. So that's what increasing and decreasing intervals look like if you don't have a picture. We'll think about it with the picture in a minute, though. The first derivative test. If c is some number you solve for, like the number 5, it's a critical number, or a continuous function f of x, then the function has a relative minimum value at c if the derivative switches signs from negative to positive. More about that once we draw it. And the opposite is true. Relative max if the derivative switches sign from positive to negative. Negative to positive, positive. We'll see what we mean in a second. Because right now it would be just memorizing stuff, and I don't want you to memorize this. We'll talk about it in a minute. So first, find the open intervals on which the function is increasing or decreasing. Find the coordinates of any relative extreme. Now, I take a look at this. First, if I think, oh, it's a rational function. No, it's a line, right? There's no divide by x portions of it. And for calculus reasons, I'd rather think of this as 1/2 x minus 3, right? Distribute the divide by 2. So I'm going to write that out first. 6 divided by 2. Then, I think we know enough about linear functions to know that they don't change. It's either increasing at a steady rate or decreasing at a steady rate. We have the slope, and it doesn't change, right? It's constant. It's a slope of 1/2. So we know the answer ahead of time, mx plus b. So we could tell that it goes up 1 over 2, up 1 over 2. So we know the answer. So let's use our new calculus concepts on a question where we know the answer. Okay? So I'm going to go with prime of x on which the function is increasing or decreasing and coordinates of any relative extreme. So I'm going to see where if this derivative, without knowing anything, what is it? It's 1/2, right? And it's only 1/2. It's positive 1/2. It doesn't change. When x is negative 5, it's 1/2. When x is positive 17, it's 1/2, right? Positive. So at all points, it is increasing. All points on the domain, which is all real numbers. Is there any relative extrema? Does this ever switch signs from positive to negative? No. So there's no maxes or mins because I haven't stated a small, oh gosh, closed interval. Then I could say there's a max and min, but this is from negative infinity to positive infinity. No maxes and mins, no extremes. So we just say the open interval on which it's increasing, increasing, put a dot, on, and we'll use round bracket, negative infinity to positive infinity. Why is it increasing on there? Since f prime of x is greater than 0. Since it's positive. But I want to say greater than 0. Let's keep with that. Now, this graph here, and I said I'd address some things about graph shapes. Now, I don't care, but where you put this one here. This is approximately what that graph looks like, right? It's a straight line, increasing from left to right. You can tell this is increasing, and according to the increasing decreasing test, the derivative is greater than 0 for most for all values on the domain. Now, what about this function? Is this increasing or decreasing from left to right? Now, this is more like it. This is where the slope is actually changing, but it's still increasing, right? So what about, so this is increasing the whole time. Basically, as long as the general trend is this. How about this one? Now, I'm exaggerating some things here. How's this one looking? It's increasing. But isn't the slope 0 right here? In here? It is. But what does the rule say? This is why I want to point this out. With the exception of a finite, and that means a countable, number of points where the derivative is 0. As long as it's greater than 0, and you can have the exception of a few points where it does level up, but it continues increasing, then it's fine. Does that make sense? Okay. It's so long as this is still increasing. Okay. What you can't have is it going like this. Sure, the general trend is increasing, but it goes increase, decrease, right? Okay. Last thing. What do they mean by the derivative doesn't exist, but it's still increasing? How about this one? This is still increasing. This is sort of that scenario in the rule. It's increasing from left to right. Definitely increasing for the first portion, right? The derivative doesn't exist at this corner, right? Because from the left you get a different value than you would for the slope on the right. It doesn't exist there, but it's still an increasing function. Do you guys follow me on that? Okay. So that's what's being referred to in these rules. Now, giddy up, I got a couple more to take a look at, okay? Any questions about just what those rules meant? No? Find the open interval where it's increasing or decreasing. Then find the coordinates of any relative extremes. This one has some. So we do the derivative first. You guys do it, I do it, we compare. This one's set up actually so that it has nice derivatives. Once you do the derivative, you set it equal to 0, because that's where your possible critical numbers are. There's no way that this could be undefined, so critical numbers, I like to state that, 0 equals x squared plus x minus 12. I factor it. Now, this one requires some extra steps. The other one we knew was a line and it didn't change signs, etc. I want to pause and make sure everybody's with me on the critical number idea. By the way, the previous question I said it, but I didn't write it down. No critical numbers. What the heck? Anyways, about, are you okay? If you need to do something to refresh yourself, go ahead. Okay, anyways, what do we do? Sign analysis. Remember doing sign analysis on a chart when we were doing greater inequalities stuff? we're basically looking at positives or negatives, inequality kind of ideas. So what we do is we analyze the derivative and do it in factored form. So I take the factors of the derivative because it's easier to think about. I'm going to list them here. It's x plus 4 and then x minus 3. I'm listing them stacked like this. And if I was dividing by something, I'd put it underneath there too because I'm thinking one factor of it at a time. Now my number line, don't populate it with 0 necessarily in 1, 2, 3. I'm only interested in negative 4 and positive 3, so that's all I put up. Now you'll notice my color coding, green 3 matches to the x minus 3. Okay, so blue. So I look at the factor x minus 4. Here's what I'm wondering. Where is it 0? Where is it positive? Where is it negative? The zones. So I look here. If I put in negative 4, I get a 0 from this factor, x plus 4. Anything higher, and do a quick check in your head. Okay, so negative 3 plus 4, yeah, it's positive. And I'm going to put it in this zone as well, even though that doesn't, logically it shouldn't change, right? But I'm just going to line things up with the other numbers. So in between negative 4 and 3, above 3, it's still positive. Below negative 4, so I put negative 5 in, or negative 1 million, I get negative values out of this. Put this down for your factors. Then you do the green machine. X minus 3 gives me a 0 at the number 3. Anything larger than 3 will give me a positive. Anything smaller than 3 will give me a negative in this zone, or smaller than negative 4 as well. Why did I do this? Because this is the derivative, right? Whether the derivative is positive or negative tells me where it rises or falls. Potentially switching at the zeros. So this means if I put in a number smaller than negative 4, so negative 5, if I put negative 5 into this expression here, what kind of answer are you going to get? You're going to get a positive. Rather than testing a bunch of numbers, though, like into this original thing, I'm saying, well, I just get a negative times a negative according to these factors, which you've done anyways. I'm going to get a positive result. Then, a positive and a negative. So I'm going to get a negative result, and then I'm going to get a positive result. Now, this helps you organize your thinking. It does not answer your question. After this, underneath, I'm going to ask you guys to do a quick line sketch. Hashim, do you remember doing this line sketch? Okay, you might want to do this. What does positive mean? As I've said this, when the derivative is positive, what does it tell you about the function? Increasing. So draw a stick underneath. No curves, but it goes up to negative 4, it's increasing. Between negative 4 and negative 3, it's decreasing. Then it's increasing. Now this is just descriptive to organize your thought. Now you know, you remember this, right? This way, this also tells me not just where it's increasing, decreasing, but intuitively tells me where my maximum would be. Where would your maximum be? At negative 4, right? Instead of memorizing with words, because it looks like it increases, then decreases. The derivative switches sides from positive to negative. And I said, don't memorize this. So you've got a relative maximum. The function has a maximum if the derivative switches sign from positive to negative. Honestly, if you memorize that, that makes no sense in your head. But if you visualize this, I don't think it's hard to memorize, is it? Okay, so it switches signs from positive to negative. That's why that's a maximum value at negative 4. Negative to positive, you can see right away that it's a minimum value at positive 3. You can see my cord is getting shaken up too. Okay, so we've got a few things to state here. What are we asked for? Find the coordinates of any extremes? Oh, golly. Well, you'd put it in there. You know what? I'm lucky. I've done them before. You guys are lucky. Just for time-saving reasons, I'm going to find out f of negative 4 is equal to, I did the arithmetic last year, kids, 116 over 3. F of 3, you guys got calculators, so 2. Negative 37 over 2. Okay?
You're plugging that into the original?
Yes. This is not f prime. This is the function. Right? If I plugged f of negative 4 into the f prime, what should I get? 0. So we've got a bunch of stuff to report now. Relative maximum, relative minimum. Relative max, now it's asked for the coordinates, at negative 4, comma, 16 over 3. Since, and if you guys used a decimal, I'm old and fuddy-duddy and stuff like this, so I give you fractions and stuff. If it's not fractions that are like 1/2, 3/5, 2 out of 7 or something like this. Something like this, I'm fine with the decimal. Remind me, if I mark you half wrong or something, say, Shintaka, take a pill, relax, use decimals. Okay, sometimes I will. Relative max at negative 4. Why? Since the derivative, tell me what rule you use, switches positive to negative. Okay, switches signs at that point. Some of this statement is implied. Right? Relative min at 3, negative 37. Oh, I can't talk. Negative 30. 37 over 2. Since the derivative switches signs from, as you can take a look above at our diagram, negative to positive. The other thing we were told to report, so even though you have basically everything here, you're just reinterpreting our sign analysis in words, right? You're telling me you know what this means. You've just told me you recognize that if it increases and then decreases, you got a maximum. You've told me you recognize that decreasing followed by increasing portion gives me a minimum. Seems common sense. There's a lot of ideas to get to this point. The last thing is intervals of increase and decrease. I've got them identified with symbols, increasing intervals there and there, and then the decreasing in the middle. So, what do you want? Increasing on. I like the function is increasing on. I'll tell you a little bit of shit. Negative infinity to negative 4. In union with and greater infinity. And that's since it's positive. Okay. Since prime of x is greater than 0. Decrease or negative 4 to 3. These x values. Since is less than 0. Right? Now, that was a whole whack of stuff we went through. I've done a lot of math. Yeah. Hope you guys are on with this. Now I'm going to just see. I think the questions are given. Okay, I'll pause this. Okay.